Then you know what is inert gases? Noble gases or inert gases or rare gases. Already I told you p block elements is very important because all the important groups like 18th group namely inert gases, 17th group halogens, 16th group chalcogens, then 13th group boron family, 14th group carbon family, 15th group nitrogen family. So very important families. In the periodic table, the 18th group namely inert gases or rare gases or noble gases, isn't it? What are the elements present in inert gases? Helium, neon, argon, krypton, xenon, radon. These are present in 18th group. Okay. Why this named as inert gas? Outermost? That means inert, huh? This is how completely filled NS to NP6 electronic configuration, so that when you have some amount of acid or alkali or whatever it is, nothing will take place. No reaction. No reaction. Simply inert in nature. So that this named as inert gases. Which gases? Inert gases. Okay. Why these are called rare gas? Because very rare amount only present in our earth crust, so that rare gas. So that you can call noble gas, inert gas or rare gas. Except helium, everything has octet electronic configuration. Because helium contains only 2 electrons, the doublet rule. Remaining everything has completely filled NS2NP6 electronic configuration. The outermost shell have 8 electrons. So long as they empty vessel only can make more noise. So that inert in nature. Yeah. Now the important 5-mark question. How to isolate inert gas? Isolation of noble gas. They will ask question, how to isolate noble gas? Otherwise, explain Ramsey-Raleigh method. First one is Ramsey-Raleigh method, next one is Dewar process. Dewar process is to separate the noble gases individually. First, how to isolate from our atmosphere? Because our atmosphere contains nitrogen, oxygen and very small amount of rare gas, everything. First, initially we are going to isolate noble gases from other nitrogen, oxygen. First, we are going to isolate the noble gas, that means Ramsey-Raleigh method. How to separate individually mean separation of noble gas means that named as what? Dewar's process. Clear? So, isolation of noble gas mean Ramsey-Raleigh method. Separation of noble gas mean Dewar's process. Clear? Okay. Now, how to isolate noble gas, namely Ramsey-Raleigh process or method. Ramsey-Raleigh method. Okay. Actually, their principle is they are going to convert their oxides. Okay. Initially, they are going to take one look like a round bottom flask. Okay. See, the mixture of air and oxygen is continuously passed through a globe of containing 50-liter capacity vessel. The globe is how much? 50-liter capacity. How much capacity vessel? 50-liter capacity vessel. They are going to continuously pass what? Continuously air and oxygen. Because air contains nitrogen, oxygen and other gases also. 2 platinum electrodes are introduced. What? 2 platinum electrodes are introduced. It connected with transformer. It gives 6000 to 8000 volt. Now oxygen and nitrogen and oxygen converted into nitric oxide. Nitric oxide again reacts with excess air to form nitrogen dioxide. Now you are going to pass alkali, sodium hydroxide, you will get sodium nitrate, sodium nitrite and water molecule. Suppose excess amount of oxygen is there, mean they are going to add alkaline pyrocolol, that means everything is positive and come out. Okay. Now listen, the principle is already the air contain what? Here they are going to pass what? Tube is there, alkali, they are passing alkali. Okay, so rough diagram only, you have to draw very neat diagram. Clear? One tube will be here. Soda in, soda out and all will be there. Okay. The principle is nitrogen is converted into their oxides. Nitrogen converted into their oxide. So initially nitrogen reacts with air to form nitric oxide. This nitric oxide reacts with excess air to form nitrogen dioxide. Nitrogen dioxide. Balance side, nitrogen dioxide. This nitrogen dioxide in NO2 you are going to add sodium hydroxide, you will get sodium nitrate NaNO3 and NaNO2 and H2O. Sodium nitrate, sodium nitrite and H2O. You have to balance it. The 2 molecules of sodium mean here 2 molecules of NO2. Balanced or not? Balanced. Okay. Now for what purpose they are adding sodium hydroxide? Everything washed away and come out. Even though, so very small amount of oxygen is present inside, mean you have to add alkaline pyrocolol. Okay, that's a solvent. Everything completely washed away and collect and come down. So what is inside? Only noble gases. Because air contains nitrogen and oxygen and impurities. Nitrogen and oxygen, everything reacted to form a already reacted. It converted into nitrate, sodium nitrate to sodium nitrite. Now what is remaining? Only noble gas. That noble gas alone pumped out and collected easily. Clear? So already air contains nitrogen, oxygen and noble gases. Nitrogen and oxygen, everything already reacted. Okay, it converted into products also. So you have remaining only noble gases. The noble gases alone you can pump out and collect it very easily. Clear? Clear? Now you got which one? Ramsey-Rale method is over. Clear? Just do the Ramsey-Rale process. Just do the Ramsey-Rale process. Okay. To form nitrogen dioxide, then nitrogen dioxide reacts alkali to form respective nitrates. Sodium nitrate, sodium nitrite and water molecules. Okay. Now you isolated the noble gas. The next method is how to separate noble gases. How to separate noble gas individually, that named as DeWass process. Whose process? DeWass process. So isolation of noble gas mean which process? Isolation of noble gas mean Ramsey-Rale process. Separation of noble gas mean DeWass process. Now DeWass process. You know the noble gases: helium, neon, argon, krypton. Now radon is not present on the earth crust. Yeah, because it is a radioactive one. Whenever nuclear reaction takes place, that time alone will come out. Okay, because it is a radioactive. So in our earth crust present only 5 noble gases: helium, neon, argon, krypton, radon. Using which principle you can isolate, you can separate the noble gas mean the coconut charcoal adsorb the noble gases at different temperatures. Okay, coconut charcoal have very one important behavior property, namely it adsorption Coconut charcoal absorbs the noble gases at different temperatures. Using this principle only we are going to separate the noble gases individually. Clear? Okay. How it absorbed mean? See, initially one double wall tube containing charcoal fully what? Cold path fully cold path, that means fully what? Ice, cold path. One more Devar flask. Here only coconut charcoal, a double wall tube. Now we are going to allow the noble gases at 173 Kelvin. We are going to keep inside at half an hour. How much Kelvin? At 173 Kelvin. At 173 Kelvin, argon, krypton, xenon are absorbed. What is remaining? Helium and neon. So double wall tube containing coconut charcoal. Coconut charcoal is absorbed the noble gases at different temperatures. Initially at 173 Kelvin, you are going to introduce the noble gases inside. You are going to keep 173 Kelvin at half an hour. That time argon, krypton, xenon are absorbed at 173 Kelvin. Remaining what? Helium and neon pumped out and collected. Okay. Then the mixture of helium and neon is kept in contact with another coconut charcoal at 93 Kelvin. How much Kelvin? 93 Kelvin. That time neon will absorbed at 93 Kelvin. Neon will absorb whatever remaining. Neon unabsorbed. So that you can pump out and collected. Now you got individually helium separately and neon separately. What's the problem? Still argon, krypton, xenon is all together is there. So how to separate argon, krypton, xenon mean? See, the charcoal 173 Kelvin still containing argon, krypton, xenon is placed to contact with another charcoal at temperature of liquid air. That time argon diffuse into another charcoal. Temperature of liquid air. That time argon diffuse into another charcoal. So what is remaining? Krypton and xenon. You can pump out and collected. Now we are going to increase the temperature from 173 to 183 Kelvin. That time xenon will absorb. What is remaining? Krypton, that you can pump out and collected. Clear? Now you got all the inert gases individually, separately. Clear? So initially you have helium, neon, argon, krypton, xenon. Okay. One charcoal is there that containing double wall tube. Through the double wall tube, we are going to pass noble gases. We are going to keep half an hour. That time at 173 Kelvin, argon, krypton, xenon will absorbed. So what is unabsorbed one? Helium and neon. The two gases pumped out and collected. Next, at 93 Kelvin, neon will absorbed. What is unabsorbed? Helium. The unabsorbed one you can pump out and collected. Now you separated helium separately and neon separately. But still we have at 173 Kelvin, krypton, argon, krypton, xenon is there. How to separate? Okay. At liquid air temperature, that argon will diffuse into another charcoal. So very unabsorbed mean krypton and xenon. We have to separate that also. So just we are going to increase the temperature from 173 to 183 Kelvin. That time xenon will absorb easily. What is remaining? Last unabsorbed xenon. That we can krypton, that we can pump out and collected. Clear? Now you got all the individual noble gases separately. This named as Dewar's method. Clear? Any doubt? Dewar's process is important 5-mark question. The next important questions mean They can ask uses of noble gases: helium, neon, argon, krypton, and xenon and radon. Uses mean you can read all the uses. Helium, helium oxygen mixer. The deep sea divers are using helium oxygen mixer. Then helium oxygen mixer is used in asthma. This is one more question. Okay. See, because of lightness and non-inflammability, helium is used to filling balloons in meteorological observations. Because of lightness, used for inflating aeroplane tires. Helium oxygen mixer is using deep sea divers. So mixer of oxygen with helium is used for treatment of asthma. Liquid helium is a cryogenic agent for carrying all experiments at very low temperature. Then neon, already we discussed in 3-mark part. Argon, mixed with 25% of nitrogen, used for filling electric lamps, used in radio valve tubes. Krypton and xenon are also used for filling incandescent metal filament in electric bulbs. They are also used small extent in discharge tubes. Radon is a radioactive research and radiotherapy for treatment of cancer. P-block element is over. Clear? So in that lesson, the 3 marks part mean what is inert pair effect. The less availability of NS electron in bond formation, nothing but inert pair effect. Going down the group, inert pair effect increases. What is potash alum? KTSO4, AlTSO4 thrice, dot 24H2O. Is prepared from alunite or alum stone. KTSO4, AlTSO4 thrice, 4 times of aluminum hydroxide. பொட்டாசாலம் படிகாரம் வீட்டுக்கு முன்னாடி தேங்காய் பெரிய ஒரு கல்கண்டு மாதிரி இந்த சத்தியோட படிகாரம். That's okay. So how to prepare potasalam mean from alunite or alum stone. The powdered alunite or alum stone is boiled with dilute sulfuric acid. That time the aluminum hydroxide part converted into aluminum sulfate. Now little more potassium sulfate is added. Alum is crystallized. Clear? What is burnt alum? Potash alum is heated at 365 Kelvin. It all water molecules evaporate. The swollen mass are known as burnt alum. Okay, what is the uses? It fills the water and arrest bleeding also. Okay. Then, what is the plumbo solvency? Lead is not attacked by pure water in the absence of air. But air dissolved water has a solvent oxygen in it to form one poisonous substance, namely lead hydroxide. This process named as plumbo solvency. Pb, lead plus oxygen plus water, it gives lead hydroxide. The next one is electron dot structure of PCl3, PCl5, H3PO3, H3PO4, H4P2O7, HPO3. That's what structure of HPO3. Electron dot structure of PCl3, PCl5, phosphorus acid, phosphoric acid, pyrophosphoric acid. H3PO3 mean phosphorus acid. H3PO4 mean orthophosphoric acid. H4P2O7 mean pyrophosphoric acid. HPO3 mean metaphosphoric acid. Clear? Prove phosphorus pentoxide is the best dehydrating agent. Sulfuric acid gives sulfur trioxide. Nitric acid gives nitrogen pentoxide. Amide gives nitrile. Okay. Phosphorus acid is a dibasic. Why? Because it reacts with alkali, it gives 2 different types of salt. Sodium dihydrogen phosphate, disodium hydrogen phosphate. Orthophosphoric acid acts as the tribasic. Why? reacts with salt, base, it gives three different types of salt. Sodium dihydrogen phosphate, disodium hydrogen phosphate, sodium phosphate. Then you know all the electron dot structures. Hole signal. Take one container, the hole, you have to keep calcium phosphide and calcium carbide. They are going to thrown inside the sea. Now seawater enters into the container. Calcium carbide produce phosphine. Calcium carbide produce acetylene. Now phosphine combines with acetylene. It ignites. It gives bright red light along with large amount of smoke. This indicates just for signal for ships. Then explain the oxidation nature of fluorine. Fluorine oxidizes halide to halogen. Halide to halogen. Edging of glass. You know how silicates, glass mean made up of what? Silicates and silica. It attack very easily HF. Okay, it converted into solid Na2SiF4 and Na2SiF6 and Si4. Dash used as flux in metallurgy. CaF2. Interhalogen compounds. You know how to form interhalogen compounds? Out of two halogen, which halogen have less electronegativity, that only have to write first. Okay. Xenon fluoride compounds. Xenon reacts with fluorine, it gives xenon difluoride. 2 molecules mean tetrafluoride. 3 molecules mean hexafluoride. Uses of neon. They are asking frequently uses of neon. Others also they can ask. 5 more part. How to prepare potassium preparation properties uses. Then silicone structure. Uses of silicone. Metallurgy of lead. Then anomalous nature of fluorine. Any 5 points? Read all the points. Dash attack class. HF is weak acid or strong acid? Weak acid. How to isolate fluorine? Dennis method. How to isolate fluorine, not gas. How to isolate fluorine? Dennis method. How to isolate noble gas? How to separate noble gas? Don't confuse. How to isolate fluorine mean Dennis method. How to isolate noble gas mean Ramsey-Raleigh method. Interhalogen compounds. Any two they will ask in 5 more part. Maybe AX or AX5, AX, AX5 or AX3, AX5 or AX3, AX7. How to separate noble gases? DeVos process. Uses. Uses of noble gases. Helium, neon, argon, krypton, xenon and radon. So these are the important 5 more questions. Okay. Okay, another doubt in P block elements? One more question. Huh? You need one more question. And the temperature heat பண்றாங்க. They are heating at liquid temperature. இல்ல liquid temperature. அந்த focus கொடுத்துறாங்க இல்லையா டேபிள் கஸ்டம். Liquid temperature போட்டா போதும். Which of the following does not belong to group number 13? Group 13 mean boron family, the first group. Okay. So, what's the correct answer? Germanium, Ge. Which of the following is almost abundant in earth crust? The element which was burnt in limited supply of air, they give oxide A, which on treatment with water gives an acid B. An acid B and heating it gives C, which gives yellow precipitate with silver nitrate solution. A is P2O3, phosphorus trioxide. The compound which is garlic odor, garlic taste. 2 1 more question is available. One is garlic water, another one is garlic taste. Okay. Which one is garlic water? P2, garlic taste, H is PO3. H3, PO3. Then shape of PCl5, trigonal, bipyramidal. The compound uses smoke screen, PH3. Which one shows negative oxidation state? -1. Because fluorine have highly electronegative element, so that minus negative oxidation state is possible, -1. But other halides and all positive as well as negative. One can draw the map on building on glass plate by, because HF attacks glass, others do not. Okay. Because HF attacks glass, others do not. Halogen belongs to group number. Halogen belongs to group number. Inert gases. Inert gases. Salgogens. 16th. Noble gases are unreactive because stable electronic configuration like NS2 NP6 electronic completely filled electronic configuration. The shape of xenon tetrafluoride, square planar, which is not known, ArF6. Lightest gas which is non-inflammable. Which of the following has highest forced ionization energy? Highest forced ionization energy? Helium, because very small one. The fastest will have 2 electrons. You can't remove very easily because very closest to the nucleus. Okay. Very large amount of energy required to remove the electrons. So that helium is the correct answer. Clear? Any doubt? Any doubt? So P-block elements completed. Next class we will discuss next lesson. Okay. Okay. Thank you, students.